In this video, we'll be discussing solving systems of nonlinear equations using the elimination method or the addition method. And this is the exact same technique we use when we're solving systems of linear equations by elimination. So you want to start by arranging each equation so like terms align vertically. You're going to multiply one or both equations by the appropriate numbers so the coefficients of one of the variables are opposites. Remember, we want to be able to add down and have one of the variables fall out. So if it doesn't, we need to multiply so that our coefficients are opposites. So then we'll add down and one of our variables should drop out. We'll solve for the remaining variable, and then we'll substitute this value into one of the original equations and solve for the other variable. And as always, we can check our solutions by plugging our ordered pair into both original equations. So solving here by elimination, I see that everything is already like terms are aligned vertically, but coefficients aren't opposite, so when I add down, nothing falls out. So I just want to see what I can do. I notice that if I multiply the bottom equation here by 2, then my y's, make that a -2, then my y's will have opposite coefficients, and when I add down, they'll fall out. We could have had the x squareds fall out, but that would have required more work. We would have had to multiply both equations by a number, so I always just look for what's going to be less work. So that's going to give us 3x squared minus 2y squared equals -5, and -4x squared plus 2y squared equal to 4. Now, sometimes I'll see students kind of be lazy and not wanting to rewrite both equations, and frequently I see them make mistakes. So take the extra 5 seconds to rewrite both equations. Don't try to like leapfrog and look at this one and that one and not rewrite it. Now when we add down, our y's fall out. We're left with -x squared equals -1. And I'm going to solve this quadratic equation using square root property. We'll start by dividing both sides by -1, giving us x squared equals +1. And then square root property, that's going to give us x equals plus or minus 1. So since I have 2 solutions for x, I know right away I'm going to have at least 2 solutions. And now I need to choose plug each of these x values into one of my original equations and solve for y. This is a little bit longer process than the substitution method when you're plugging back in. So starting with x equals 1, plugging that in. And again, I kind of just look for what I think is the easier equation. I think I'm going to choose the bottom one before I multiplied it by -2. And I'm choosing that just because the coefficient on y is only -1 instead of -2. So cleaning this up, it's 1 times 2. -y squared is going to be equal to -4. I'll go with square root property again, so we'll just divide by 1, or -1. And then square root property. I'm actually going to get 2 values for y here. We're going to get y equals plus or minus 2. So taking my x value of 1, and it has these 2 y values, that's actually going to give us 2 ordered pairs right here. 1, 2, and 1, -2. Now let's plug in x equals -1. Negative 1 squared is 1 times 2 is 2. Square root property again, so let's isolate our y squared. Y squared is equal to 4. We take the square root of both sides, and again we get two solutions for y. We get y to be equal to plus or minus 2. So we're taking our x value of negative 1 with each of these two y values. That's going to give us two more ordered pairs. Negative 1, 2, and negative 1, negative 2. This system of nonlinear equation actually has four solutions. And if we think about it graphically for a minute, looking at both of our original equations, since x and y are both squared and one has a positive coefficient and the other has a negative coefficient, we know that these are both hyperbolas. And if we think about it graphically, and they're both pointing up since the x is positive, I could have one like this and one like, and then the other one like this. And that's giving us those four intersection points, which correspond to these four solutions that we got.